Learning target 5 is using sum or difference identities for sine, cosine, and tangent to find the exact value of an expression. So I'm giving you a brand new set of identities, but you don't have to memorize them because they're on the red sheet for your pre-calculus formula sheet, so you have them, all right? You have to know how to use them, though, but at least you'll have the actual identity. You don't have to memorize these, okay? So if you have two different angles, we'll just give cosine to start with and give an example, and then we'll do first half of learning target 5. I think that makes more sense when we actually do an actual example. But if you have two angles, our book calls them alpha and beta. You can call them x and y. I don't care. You have two angles, all right? And you decide to add them together, all right? So you want to add 20 degrees to 70 degrees, or 20 degrees to 45 degrees, or whatever. You want to add two angles, right? You can't just add the cosines of both of those, all right? So if you're going to do cosine of 20 degrees plus 70 degrees, you can't just do, oh, I'm going to add those together. There's a formula for this, all right? So here is the sum and difference identity for cosine. Now, it seems like it's a lot, but it's not that bad. Notice the symbols in between, all right? It's just putting both the identities together. I'm going to separate them out for you, but just putting both of them together. On the formula sheet, they're written this way, so I need to see them this way. But it's just all jammed together instead of separate. If I wanted to find a sum, then I would have cosine of alpha plus beta, or x plus y, just two different angles. And that would be cosine of alpha and cosine of beta. And to do the symbols, whatever symbol you're using, the top or the bottom symbol, then use the same symbol on the other part at the top or the bottom. So since we're using a sum, that's the top symbol, so I'm going to follow it across the top. All right? So sine alpha, sine beta. If I wanted to do the difference, then you have cosine of alpha minus beta, or x minus y, because you're subtracting. But again, you follow the signs. So we're using the bottom symbol. So we use the bottom symbol in the identity.
We can just use x and y.
Yeah, you can use x and y instead of alpha and beta if you want to. Does everyone understand where the symbols came from, though? Well, like, understand how I separated them the way I did. If you're using addition, that means you have the plus on the top, so use whatever symbols on the top over on the other side. Okay. Again, on the red sheet, they're all the jammed together version, so you just need to know how to separate them. So everyone's good that those are two different identities jammed together for cosine. There's also sum and difference identities for sine and tangent. I am not going to take the time to separate them out for you. You can if you want to. Again, you just follow the symbols. If you started with the top symbol, then you use all the symbols on the top. If you started with the bottom symbol, you use all the symbols on the bottom. Mm-hmm. Right. So you can separate them out on your note sheet if you want to. I'm just not going to separate them for you. Make sure you have the sine identity and the tangent identity at least written down. If you want to separate them on your note sheet, you can. I gave you space for that, but you don't have to. But you do need to have the general identity written down. You follow the symbols. So if you're doing the sum for sine, then you have a plus sign in the middle because it was on top. You follow the symbols, whatever it says in the identity. No, you follow the symbols in the individual identity. In cosine, if you are adding, that's the top symbol, so we're going to use the top symbol over here, that's subtraction. For sine, if we're adding, we use the top symbol over here, and that's still addition. It depends on the identity. You have to be able to follow the symbols. Again, if you're using the ones on the top, Use all the ones on the top. Using the one on the bottom, use all the ones on the bottom. So like tangent has multiple signs in it. Does everyone have at least, at the very least, the cosine identity, the sine, and tangent identity written down? You don't have to have them separated, but you have to have those three written down. Yes or no?
No.
Okay. You just might want them for your homework. For tangent? Yeah, if you're adding, you have tangent of A plus B, and then the numerator tangent of A plus B, and the denominator 1 minus the tangent of A times tangent of B. Then use X and Y. I told you that already. You don't have to use A and B or alpha or beta. You can use X and Y. It's just two variables. It represents two different angles. Use whatever letters you want to. Does everyone have the identities written down? All right, there are two types of problems we're going to do in Learn Target 5. We're only doing one type today. So we're just doing the three on the next page. Now listen very carefully. Not the first example, but the other two. If you write large, then either you need to force yourself to write small, or you may want to use your own piece of paper and not my note sheet, because some of these are going to involve extensive amounts of work. Algebra, not pre-calculus. But the pre-calculus step is going to be the easy part. Nope, that's simplify. That's the algebra part. All right. So, the reason I told you to have a unit circle. On all of these, we are looking for exact values. An exact value means we don't have a decimal. We have something in fraction form, generally with some sort of radical or something in it. Okay? So if I'm going to find the exact value of any of the angles on the unit circle, they're all there. They're in the coordinate. That's the whole point of the unit circle. Like I could say, oh, the sine of 60 is the square root of 3 over 2. All right? That's finding exact values. However, not every single angle measure is on the unit circle. So that's why you have to use these identities. So, for example, on the first one, it says to find cosine of 165 degrees. 165 degrees, not on the unit circle. But I could use the identity, or I have to add or subtract two angles to get 165. So I could pick any two angles I wanted to on the unit circle that added up to 165, or you could subtract to get 165, and then I have this identity that I can use. So someone named two angles, let's just stick with addition, that you guys can add to get 165 degrees on the unit circle. Two angles you can add to get 165 degrees. 135 and 30 add up to 165 degrees. 135 and 30, both on the unit circle. Okay? So you have cosine plus 135. You can do the order you want to. You can do 135 plus 30. I don't care. So I have my alpha, my beta, or my x, my y, whatever you're using. And I have this identity. Okay, so I'm just going to fill in the identity. So equals cosine of alpha, that's 30, times cosine of beta, which is 135. I follow the symbols. I'm doing additions. That's on the top, so I'm using the symbol on the top and the middle, so that's minus. Sine of 30 times the sine of 135. All I did was fill everything in to the formula. Now, all of you guys are trying to use your calculators. Ain't going to work very well. So I use the unit circle. So we're trying to find exact values. I have radical city, so your calculator ain't going to help you. Sorry. All right, so we're going to use the unit circle to find all these values. So cosine of 30, if you look at the unit circle, is square root of 3 over 2. Cosine of 135 is negative square root of 2 over 2. From the unit circle. Find those values. The sine of 30 is 1/2. And the sine of 135 is the square root of 2 over 2. So all I've done is found two angles to add together to get 165, rewritten it using the identity, and then filling in the identity with stuff from the unit circle. Question so far? So now I just need to do some simplification. This won't be that bad. This one's not a problem. So when you're multiplying fractions, you just multiply straight across. When you're multiplying radicals, you can multiply the numbers underneath the radicals. So the square root of 3 times negative square root of 2 is negative square root of 6. And 2 times 2 is 4. And then 1 times the square root of 2 is the square root of 2. Again, 2 times 2 is 4. And we just want to write it as one fraction. That wasn't that bad. Yeah, there's nothing to simplify. Square root of 6 doesn't simplify at all. You can't subtract radicals like you can multiply them. That doesn't work. So that's the best we can do. There's nothing to cancel out with a 4. So that's as simplified as we can get. Questions about the first example? About why did any of those steps? Any questions? Again, had the identity, I filled it in, used the unit circle, just did some multiplying. Put it all together. We good? All right. The next one's the one we're going to need some space. All right, first of all, we have tangent of pi over 12. So pi over 12 is a radian measure. And no offense, but the majority of you guys suck at fractions. So if you're trying to find two radian measures that you could add or subtract to get pi over 12, that means we have to get a common denominator, and that's just, it's going to go badly for us. So I would advise if you have radian measures to change them to degrees first. That way you can just look at all the degrees, right? Because the radians degrees are equivalent, so it's not a big deal. So how to change radians to degrees? Correct. So the pi's cancel out, you get 180 over 12, and 180 over 12 ends up being 15. All right, so we have this identity, because 15 degrees is not in the unit circle. Now here there are like multiple answers, several possibilities. Doesn't matter. We're only going to do it one way here, but there are several ways you could have gotten to the answer on this one. So you can't add anything to get 15. That's not going to work. Okay? So I need two angles you can subtract to get 15 degrees. Whoever speaks first, that's what we're using. 15 is not on the unit circle. 45 and 30. Perfect. Again, this is not the only way you could do it. All right, then we need to fill in this identity. So you're going to need lots of space, by the way. Tangent of 45. We're subtracting, so we're going to use the symbols in the bottom. So minus tangent of 30. 1 plus tangent of 45 times tangent Oh, third. Yeah. Tangent of 45 is easy. What's the tangent of 45? 1. Right? Because tangent is y divided by x or sine divided by cosine. And you have the square root of 2 over 2 divided by the square root of 2 over 2. So those are 1. Tangent of 30, not so simple. So sidebar, you can write it down or not. But you do sine divided by cosine. So you have 1/2 divided by the square root of 3 over 2. So you'll need to multiply by the reciprocal. And then rationalize. Tangent of 30 is the square root of 3 over 3. Everyone good so far? Okay. Well, here's where we got algebra issues. Not even close. We're doing so much algebra on this question, it's gonna blow your mind. It's gonna be extensive. Nope. Nope. Okay. So 1 times the square root of 3 over 3 is just square root of 3 over 3. So I don't even need this 1 here, really. And the problem is I can't have a fraction in the denominator. I definitely can't have a radical in the denominator. Okay, so the easiest way to get rid of this, and I'm telling you this is because you're going to use it on like every single tangent question. The easiest way to get rid of this is to use the conjugate. Right, so 1 minus the square root of 3 over 3. You haven't even seen all of it yet. Like, you think this part's bad. It's not. Right? I try to inspire math greatness every day. Okay, so questions about why using 1 minus?
Yeah, that one that one says 1 minus. Why are you using 1 minus and what?
The conjugate is based off the denominator. We're using 1 plus in the denominator, so you have to do the opposite. Okay, so then we're going to FOIL the numerator and the denominator. I understand that some of you guys don't need to write all the steps out. I'm going to write all the steps out so that no one gets lost. Okay? So, great. So we're going to FOIL. 1 times 1 is 1. 1 times negative square root of 3 over 3 is negative square root of 3 over 3. The negative square root of 3 over 3 times 1 is another negative square root of 3 over 3. And then negative square root of 3 over 3 times negative square root of 3 over 3 is positive square root of 9 over 9. I know we can simplify that. Again, I'm just making sure everyone got all the pieces. I'll go back and work on that and simplify that later. Questions about the numerator? In the denominator, we do the same thing. 1 times 1 is 1. 1 times negative square root of 3 over 3 is negative square root of 3 over 3. Positive square root of 3 over 3 times 1 is positive square root of 3 over 3. And positive square root of 3 over 3 times negative square root of 3 over 3 is negative square root of 9 over 9. Any questions about where any of those numbers came from? Any questions about where any of those numbers came from? The square root of 9 is 3, so you have 3 over 9. And 3 over 9 is 1/3. So I could change both of these. I want to be able to combine all of the fractions in the numerator and the ones in the denominator. So in common denominators, everything has a 3 except for the 1. So we'll change these to 3 over 3. So then everything has a common denominator. What's the matter? The square root of 9 is 3 over 9. So you had square root of 9 over 9, right? So now you have 3 over 9. And 3 over 9 reduces down to 1/3. So that everything has a common denominator. Too bad. All right, questions so far about this? All right, so we're going to combine the numerator. You have 3 plus 1, that's 4 over 3. And then you have 2 square roots of 3 over 3. You can combine that into one fraction. I'm going to do it in a second.
Hold on. Before you move on.
I added 3 and 1 and got 4.
Right, I saw that part.
And then I combined the square roots of 3. There's 2 of them.
Okay, you're not supposed to either. Oh.
You're with me. You're good. And the denominator, the negative square root of 3 and the positive square root of 3 cancel each other out. That's 0. And then you have 3 over 3 minus 1 over 3, so that's 2 over 3. Right. So you have 4 minus 2 square roots of 3 over 3. That's the numerator, all combined. When you're dividing fractions, you multiply by the reciprocal. And times 3 over 2. If you want to do it that way. I'm just going to cancel the 3's out. Everyone, we're almost done. Yeah, you can distribute the 3. I need to have 12 minus 6 over the square root of 3 over 6. Uh-huh.
So what are we going to do now?
Mm-hmm. Yeah, so then we just simplify. We split this into 2 fractions. 4 divided by 2 is 2. 2 divided by 2 is 1.
Oh my god. Oh, it is not 1. How many problems do we have with this? Let me guess. 666.
I think it's 5, but 2 of them end up being the same problem.
So there's 5, but there's 2. 5 plus 2 is 7.
No, there's 5 questions. There's 5 questions for the homework on this part. But the first 2 end up being the same, like one's in degrees and one's in radians, end up being the exact same. So there's only 4.
We don't have to.
Like the second one, you already know the answer to, so you should write the answer down, don't do all the work.
For real? You won't take
So you have to do 4. No, my homework key says see the one above. All right, questions of the tangent question. I know, lots of algebra. I told you ahead of time. Okay, I told you ahead of
You
time.
tell us this much, you're like, you know
I
what?
said extensive. I said extensive. This was extensive.
First off, I don't even know what that is. So there's
Yes, Cyrus.
So, if we're taking a quiz. We get that wrong just because that's a one little step. The whole thing is wrong.
You're going to have to show your work just like on the last quiz.
No, I don't think it's very long.
You haven't finished the last one, so I don't know.
This
All right. Can I erase all this? All right, I have one more example. Yeah, this one doesn't take as long. All right, one more example. A few things. First of all, it's asking for secant. There isn't a secant identity for sums and differences, so which one we're going to use? Cosine. So we're going to use cosine and flip it over, or you can flip it over from the beginning, whatever you want to do, but you're going to use cosine. Also, you need to find an angle coterminal, so you need to find one between 0 and 360. Correct, and you actually have to do it twice, and you get 75. You have to find an angle between 0 and 360, like we did way back in Unit 1.
So wait, this is for
45 and 30.
A coterminal angle. That means one between 0 and 360.
Right, but so you just need okay. Equal 795.
That's equivalent to 795. So So you subtract 2 rotations.
So it'd be like, what, 360 and...
So you take 795 and you subtract 360, and subtract 360 again until you get between 0 and 360. So we got 75. Okay. So I have secant of 75. I'm really going to find cosine of 75 and then flip it at the end. So Brandon said a second ago that we were going to use 45 and 30. Use whatever you want, but that's what Brandon said. So we can follow the formula. So you have cosine of 45 times cosine of 30 minus sine of 45 times the sine of 30. I'm going to finish this problem first. All right, so cosine of 45 is the square root of 2 over 2. Cosine of 30 is the square root of 3 over 2. Sine of 45 is the square root of 2 over 2. Sine of 30 is 1/2. Should be looking similar to what we did earlier.
Hold on. Yeah, hold on.
You're filling in from the unit circle.
I'll put the minus sign like halfway on the screen. But, you know, if I erase it, I have to do the whole thing. So I made it darker. Hopefully, like later future meetings.
So when we multiply, we get the square root of 6 over 4 minus the square root of 2 over 4. Now, this again is cosine of 75. It'll be fine. It's not even that hard. This one takes a lot less work than the last one did. You're going to flip it over to find secant.
Oh. You like flip 4?
You find the reciprocal, because that's what secant is, the reciprocal. Again, we can't have radicals in the denominator. So you're going to use the conjugate, but this one doesn't take nearly as much time because you don't have to FOIL the numerator. You know what's going to happen in the denominator. You'll live.
How are you supposed to know how to do that?
Do
How are
what?
you supposed to know to do that?
That's what I told you to do.
But, like, if I take it from years ago?
No, that's how every single one of these is. If you have a radical in the denominator, you use the conjugate.
You know how to physics? Okay. Yeah. Well, if you won't give me the homework, I didn't figure it out.
So you distribute 4 square roots of 6 plus 4 square roots of 2 in the denominator. When you're using the conjugate, the whole point is that the middle terms drop out, so I'm not going to write them out this time. But so you have the square root of 6 times the square root of 6. That's the square root of 36, which is 6.
Oh my god.
The middle terms drop, like they cancel each other out. So then the square root of 4 is minus 2. Right, you get 4, and then the 4's cancel on both of those, so you get the square root of 6 plus the square root of 2.
Hold on.
What do we use this for? Like, is there like future math that is useful?
You have to use these identities in calculus
And what do we use the identities in calculus for?
to do calculus.
But in real life.
You're the one that wants to take calculus for some career path, not me.
Man, I'm not gonna do this. Be like, look, we put one thing here, it's gonna hold this bigger thing, and then.
All right. So on the Learning Target 5 homework, you can't do all of it because we've only done half of Learning Target 5. I'm telling you it's going to be due towards the end of the week, and if you think that the next part is going to take less time and you're going to do it and it's going to take 5 seconds, then you're wrong. All of it is going to involve a lot of work. So if you wanted to get a head start, then you would just do number 14 to 22 even. The assignment is 14 to 32 even, or something like that. We've only done half of it. So that's what you could do
Like, tonight, Tuesday?
if you wanted to get a head start.
Okay. What do you have?